In this video, I'm going to try to answer the question, why do we divide by n-1 when we calculate the sample standard deviation? So what I'm going to do is take this data set here, which is a population of pennies, and we're going to look at the age of the pennies in this population. Okay, so the first penny in the data set is 4 years old, the next penny is 15 years old, 29 years old, and so on. Okay. All right, if we scroll down, we can see the distribution of this population of pennies. The distribution is skewed to the right. There are 1,000 pennies in the population. The average age is about 12 years, and the standard deviation for the ages is about 9.6 years. So what we're going to do is we're going to take samples of 4 pennies at a time from this population, and we're going to calculate the standard deviation using both of the methods, right? The method that divides by n, as well as the method that divides by n-1. Right? And we will see which of those methods performs better. And by that, I mean which method produces a sample standard deviation that is close to the population's standard deviation of 9.6. Okay. All right, so on this website, we can draw samples of 4 pennies at a time. But the way that I'm actually going to do it is I'm going to use a different software. So this software is called StatCrunch. So what I've done is I've copied all the ages, or the ages of all 1,000 pennies. Oops, too far. Okay. You saw it. I think you saw it there. Okay. So that's all 1,000 pennies. Okay. And then the software is going to take samples of 4 pennies at a time, and then I'll have it calculate the standard deviation using the 2 methods. Okay, so let's get started. We're going to sample. The variable is the age of the penny. I'm going to sample 4 pennies at a time. Let's generate a lot of samples, right? Let's produce 10,000 samples, right? I want to see, how these 2 methods perform in the long run, right, over the course of many samples. Right. So this software has a command for calculating the standard deviation using both methods. Okay, so this command USTD uses the method of dividing by n. All right, so now I've got 10,000 standard deviations that were produced by dividing by n. We can scroll down and we can see, all right, there's a lot, right? There's 10,000. So let's remind ourselves what each of these numbers represents. Okay, so this number 5.7. Okay, we got that number by sampling 4 pennies from the population and then calculating the standard deviation using the method of dividing by n. And then 8.3, that was a result of a different sample of 4 pennies, and then we calculated the standard deviation using the divide by n method. All right, let's repeat that process, but let's use the method where we divide by n-1. So we'll sample from the ages, 4 pennies at a time. We'll produce 10,000 samples, but this time we will compute the standard deviation using the n-1 method. So that's this command in the software, std. All right, so now I have 10,000 standard deviations using the divide by n method, and I have 10,000 standard deviations using the divide by n-1 method. And now we want to see which one performed better. So we'll create some side-by-side dot plots, and we'll kind of look at where these values center. Okay, what is the average or typical standard deviation we get from these 2 methods? All right, so STD, that's the method that divides by n-1. Okay. This produces a typical standard deviation of about 8.8. The method that divides by n, that's the USTD command, produces a typical standard deviation of about 7.6. Okay, so what was the population standard deviation, right? That's the thing that we're trying to estimate. And if we go back, it was 9.6, okay? So which method, on average, produces values closest to 9.6? Right? And we would have to say it's the method that divides by n-1, right? On average, or a typical standard deviation using that method, produces a value of 8.8, which is close to 9.6. The method that divides by n produces a typical standard deviation of 7.6, which is much lower, right? It's 2 units lower. All right, so this was an argument, a simulation argument for why we should divide by n-1, because in the long run, or on average, over the course of many samples, it will produce a standard deviation that is closer to the true standard deviation from the population.